All right, I'm gonna go ahead and start the stream a little bit early when I finish my breakfast. If you're watching the recording and you're weirded out by people eating, skip ahead a little bit. Let's see. Get the shareable link. We'll put this up on the class blog. Look at me. That's me right there. Let's see if this is going to work for me this time. Let's see. Try and set up my workspace. See how much lag there is. All right, looks like a few seconds. Let's see. How do I do this? Start my timer. I'm gonna wait until I see my watch go up on the screen. Ooh, what was that? About 10 seconds? 13, 16 seconds. All right. So that's the lag from here to Mountain View and then back to here, 16 seconds. Which, hey, it's not bad. At least for office hours. So let's see what I can do with this. Let's try ultra low latency. Oh yeah, let's check the sound. Okay. Sound looks pretty good. All right. As long as I got the religious holidays in front of me, I'm aiming to do midterms, I guess, for all 4 classes, first or second week of October. Looks like we got Jewish holiday during that first full week, so probably the second week. What do we got here? That. Let's look at the academic calendar. Incomplete. Oh crap, I got a meeting I gotta remember. Pretty sure that's this Friday. Hmm. 22nd is the last day to withdraw. So, as long as I've got grades back by the 19th, I'll be fine. I think I can figure that out. All right. Other ones. Mondays, Tuesdays. All right, looks like we'll be fine. Just that first week of October. Did I post that yet? I guess I didn't. Now I have. Sorry, I just moved this window to my other monitor so that I can check my email without violating anyone's privacy. A request. Alright, so we got people signing up for the Microsoft Teams. And then what's the other thing? I'm just going to start looking at the textbook. I really should work on some of my own coding, but I'd like to read over that first chapter of the textbook first anyways. No one's out there. Not right now, maybe watching the recording. But this reminds me of the movie Moon. That's Sam Rockwell and Kevin Spacey. 2009. That was a good movie. Just a guy on the moon by himself and his clone. That's what it feels like to do office hours out into the internet. Alright, let's see. Nothing new on the blog. Done my snacks. Let's just do some reading. This is chapter 1 of Practical Data Science with R, which you can get for free, chapter 1. So I don't feel too bad about violating copyright here, because this is the freebie anyways, and this is a way worse way to get it. If you are looking for this, the Manning.com website, you search for it, you'll find this. Let's take a look at the source code. Giving me stuff. I guess I've already done this. This is our studio. That's right. That was a thing that was annoying me. Let's see, we got this. I'll come back to this. But I would like to update my keyboard so that I have a control button and an enter button, at least somewhere. I've got an idea. All right, let's see. Maximize. All right, that makes sense. All right. Here we go. Why not? Okay, and then what do I do? All right. There we go. We'll work on that code, but let me just see if this will work. There we go. All right. Anyone who is watching this, here's a slightly less boring point, besides watching me eat my breakfast. Control-Enter is a really useful hotkey here. So we're in our studio, we've got a script. We want to run this script line by line. We could run the whole thing. We could just run this source button, and it's going to run all of the code in this file that I've got right here. Let me make sure. There we go. This is the default version. So the little asterisk meant there was some sort of a change. Right, so if I put in a space, it says this version of the file hasn't been saved, but this is it as it was on my hard drive. So Control-Enter runs a line of code. And it doesn't matter if you're in the middle, that's fine. It just runs the line that you're on and moves down to the next line. Actually, I think Shift-Enter, nope, Shift-Enter isn't what I thought it was going to do. Control-Enter, that's what I want. So, Control-Enter, D not found. Oh, I think I know what I need to do. Let's see what my working directory is. No, that should be fine. You know what? It's not fine because we haven't got the actual data yet. Model example.our data. Huh. There we go. Sure, let's open it with RStudio. Yes. And that was what I wanted to do. Cool. So I loaded in this. Make a confusion matrix. So what this is telling me is based on whatever we've got in here. Let's go back to where we were. Plots, packages. What am I missing? There we go. So we've got this, a couple of things, actually, but 3 things in here. I've got this object D, which is our data. I've got this object model, which is a model that the author has already created with respect to this data. And then this confusion matrix, this is just a little table saying, of the bad loans, the model predicted 41 of actual bad loans it predicted were bad loans. 259 it predicted were actually good loans. Of actual good loans, 13 it misclassified. 259 bad loans it misclassified. And 687 good loans it correctly classified. All right, so now this data set, we've got 300 bad loans, 700 good loans. 70% of the loans are good, and we're trying to predict, is this a loan that's not going to get paid back? And basically this model says, they're all pretty much good loans. What do we got? Am I freezing again? There we go. 259 plus 687. 95% of the loans we are predicting are good loans. Let's even get a summary of this model. Resize this a little bit. Let's try this. Full screen. Summary of the model. So we used our part. This formula, the loan status, is what we're predicting here. Duration in months, so how long is this loan for? This, by the way, this data, this is actually the first time I'm seeing the data, except for what I've seen in the textbook. Do as I say, not as I do. When you guys read, you should be reading along with R. So open up the textbook, and as you're going through, hey, confusion matrix, it's right where I am. As you're going through, run any code you see. Now, for chapter 1, that's not going to matter that much, but chapter 2, you're definitely going to want to be doing that. So we got these various features of each row out of this data set we're calling D. We're classifying the data to figure out how many loans turn out good versus bad. Control, rpart.control. I actually don't know what that does. So we'll look that up. Variable importance, credit amount. This is a little tough to read. This is why we like things like graphs. But before we get too far, let's go ahead and look this up. Various parameters that control aspects of the rpart fit. Minimum split, bucket size, complexity parameter. All right. rpart. Oh, no, all right, I'm fine. All right, I'm going to go back to just reading quietly. When's our class? In an hour? All right. Oh yeah, let's look a little bit closer at this model. So the model, I was just looking at an R here. I believe this is the picture of it. There we go. Control 2, primary splits, credit amount, less than 7413. There's that. Yeah, so this is the same model. Node, we got node numbers. So this is a tree structure. A node is like a branch or I guess it's a point at which the tree branches. So node number 1, we're at the top of the tree. We've got all 1,000 observations. When we go to node 2, that's when we're saying loans that are lasting 34 months or longer. So we said primary splits, less than 34.5 months to the right. All right. Let's look at it here. It's not telling us how many loans are, or how many observations are on each one, but whatever. So, good loan. If it's a short loan for a small amount, it's probably good. Or sorry, duration longer than 34 months, no. Okay, so these are less than 34-month loans. If it's for a large amount in a short amount of time, the model predicts it's a bad loan. Otherwise, it's probably fine. If it is a long loan and it's for a small amount, they're predicting a bad loan. A long loan for a relatively large amount if it is longer than 44 months and the person has a low credit score, is this a credit score? Should read the documentation more closely. Credit amount, I don't think it's a credit score. I think this is just how much are they allowed to borrow. So someone looking for a long loan greater than 44 months, greater than 34 months also, greater than $2,250 loan, but they don't have a lot of credit, it's probably a bad loan. If they do have a good amount of credit, it is probably a good loan, although these numbers don't inspire a huge amount of confidence. But if you're doing this for a bank, scale makes up for it. You just need to be better than average many, many times. And then if it's longer than 34 months but shorter than 44 months, this model, and we're dealing with someone with some amount of credit, that's what it is. This isn't the size of the loan. This is how much credit the borrower has. Yeah, that's weird. So this is a short loan from someone with a lot of credit. We're predicting a bad loan. That looks pretty weird. Duration to the right moves us to node 2. At this point, right, what are we looking at? Node 3. Our split is credit amount compared to about 11,000. All right. Oh, here we go. Now we're actually talking about the code. Still no questions, still no one here. Yeah, so when you're doing this stuff, in this case, we actually have that example code that we were able to download. But at other points in the book, you might just follow along and say, copy this bit of code, open up a new script, paste that code in there, and just run that code. But we actually already have that here. And even though, actually two things. So one is they're actually showing you some results here. So if your question is strictly about this particular data set, about what loans are good and bad, you just read it, right? If you're the boss, you just read the results, but you're not the boss. Your job here is to learn some data science. And so it doesn't do you much good to just read, oh, there's the accuracy is 73%. What you really want to be doing is taking this code, reading it, understanding it, and even better than that would be to actually go down and say, let's, where did I put this? There we go. There we go. Looking for shortcuts on my keyboard. Actually running this code, but not just running it, but also copying it out, makes a big difference in terms of your understanding. All right, so we calculate accuracy, we see what it is. even though we've got the answer here, just going through the motions, it's a little thing, but it makes a difference. Yeah, so this is an important paragraph here. Given that our data set is 70% good loans, the easiest way to make a model that gets a lot of correct outcomes is just to say, all the loans are good loans. You're going to be right 70% of the time, but you're going to miss every single one of the bad loans. So it's a really simple rule, but it's not really what you're after. You got to kind of think harder to get what you're really after. So for our class, we're going to be going mostly through these 5 steps in this data science process. Deploying a model would be like if you work for Amazon, changing something about how the recommendations show up at your customers' computers, which obviously we're not going to do in this class. This is good advice here. That's cool. You can highlight stuff. So this first week you might be using the free preview, but this is pretty nice. Obviously you can do this with a paper copy, but this is searchable. I don't really need that to be highlighted, but you might want it to be. Those of you who are in 380, by the way, this stuff here with significance testing, you'll be seeing that in that class also. Also using R. Cool, 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 cool. Let's see. Blah, blah. Let's see this. Cool. Descriptions about how to install R and RStudio. Excellent. All right. I'm just going to take a look at this research stuff I'm working on. So if you are watching this, times it's 12:45. We got 45 more minutes. This is a Python program. Ooh, whoops. And this is an agent-based model of comparative advantage that I've been building this summer. So this code is different than R code, which is tough for me because I'm a little bit more fluent in R than I am with Python. But life is suffering, so, you know, we'll make do. All right. should be fine. Still fine over here. Oh. Oh, here we go. Best offers. That's something else. Thought maybe that was best offers for this book. Book data. Right. That shouldn't have been that. I know what happened. That makes more sense. All right, cool. Caught a bug. Getting warm. What's the weather? What do you got for me today, Illuminati? Sunny, high of 75. That's not even that bad. Feels warmer in here. Still doing that. Huh. What's going on there? Well, I didn't actually fix that. Here's a lesson in coding. Sometimes you think you fixed something, and actually notice this. This is a nice thing about this text editor I'm using. It gave me this little orange underline saying, we made this variable plan, but we didn't use it. Because I actually wanted to use it here, but forgot. Still doing it. Plan. That should be fine. Whatever. Production. Huh. Whatever. Should be okay. I don't know why it's not, but let's try this again. Still doing that. That's what it should be. Self.ppf, the plan I've normalized. It should be okay, but I think we get a glass of water. Hopefully you guys can see that message. I'll be back soon.
Still just me. All right. Oh, I should have taken that bowl down. Oh well. Oh, do. I guess technically class starts at 1:40. Something like that. We're going to start at 1:30. That. That's not what I want.
You know what? You guys are not even seeing what I'm running here. So now, again, if someone is going back through the recordings of office hours, good on you. Most of the time there's going to be a lot of nothing, at least at this rate. Hopefully that changes. But what I got here is my text editor Emacs. Really cool thing with Emacs is this section up here. This is called org mode. It's really easy to do things like add to-do items. You can even schedule stuff. Where's schedule? I guess this would be major mode. Schedule with a lower s. Let's see if I can make something tomorrow at 3 p.m. Boom. Adds a schedule to that. And then when I look up somewhere in here, find this. Oh, hey, neat. In any case, org mode's a cool little thing. You can ask the internet about it. What I'm really using it for right now is, whoop, not that. Still finding where I left all these keyboard shortcuts. Occasionally I'll hear something and look off into the distance like there's something there. I think that was just my dog scratching her ear. So, Emacs. It's a text editor. It's a really cool text editor. So over here, I've just got my 100 days of code log. I'm on day 20, although I've missed a few. I haven't actually made this an unbroken chain of 100 days, although should aim for something more like that. Maybe 100 days minus Sundays. Because I don't really get in front of my computer on Sundays. It helps me to clear my head. So I have my log. Down here, I've got actual Python. I can do stuff like, say, 2 to the power of 8 is 256. The power of 9, 512. We can do calculations. We can make things into variables. So over here, I made a variable called plan that takes on this value, which I defined in reference to the agents in this model that I'm working on. And then here I've got my actual script. So 390 students. This is actually a similar sort of a workflow to what we'll be doing with R. We might actually do a little bit more of this window plus this window kind of rolled together into one thing using R Markdown. So might go new file, R Markdown. Create something, and then you can have Markdown, which if you've never seen before, here we go. Markdown is just a really simple text format where certain symbols will mean things like make this little bit of text into a header or make this bit of text into a link. So if you look in the source to any given Wikipedia page, let's go ahead and log in so it'll actually let me. Oh, should I keep me logged in?